welcome to my 400th video. That's right, 400 videos on YouTube. I'd just like to take a sec to thank all of you watchers out there for watching videos, pressing the like button, subscribing to my channel. You support me, and it just feels great to know that you are out there learning math. So, 3 quick tips before we start. Remember, you can always pause a video at any point and catch up with your notes. You can also turn on the captions and watch my words go by on the bottom of your screen. Today's lesson covers graphs of trigonometric functions. And today we're going to talk about sine and cosine, and we're going to talk about their graphs. So as a first step, we're going to look at the very basic sine function. That's y equals sine theta. And we're going to graph that over minus 2 pi less than theta, which is less than 2 pi. So for you degrees-minded people, this is from negative 360 degrees to positive 360 degrees. So let's take a look at how that looks. Remember, what is the max of sine theta? That's 1. And the minimum value sine theta is negative 1. So the up and down is just going to be between 1 and negative 1. So I'm going to make my graph like this. And put my positive 1 there and my minus 1 there. Okay? So now let's scale our axis. Here's our 2 pi, our 360. And here's our minus 2 pi, right there, negative 360. So that covers where our graph is going to be on that range. Now all we need to do is make our curve, okay? So where is sine theta 1? That's at 90. So that's going to be right here at pi over 2. Then at 180 or pi, sine theta is back to 0. And then at 3 pi over 2, sine theta is down at negative 1. So now I have everything I need to draw this curve. What is sine 0? Sine of 0 is also 0. So we're going to go up to the peak, back down through pi, down to the bottom, and then back up. So that's a graph of sine theta from 0 to 360. Now going the other way, it's just going to be this curve going backwards. So let's get these little marks on there. This is minus pi over 2, and minus 3 pi over 2. And we're just going to continue the same process. I'm going to get this over here so it's not in the way, because we're going to drop down to there and then back up, and then up to there and then back down. And so that is the sine curve. Now, I want to caution you, don't make it a V. Like, I've got mine a little bit V-ish, but it really is a curve. Okay, so don't make it a jagged line like a W or an M or something like that. Make sure that your graph has curves to it. Make sure that the maximums line up. Like I can draw a dashed line going right across like this, and these peaks should be at 1. And the same thing for the troughs, the valleys. They should be at negative 1, like that. Okay? So there is sine of theta. Now let's talk about some vocab that we're going to need to use when we start looking at the more complicated graphs that are just variations on sine theta. But we can come up with quite a few variations. So let's take a look at some terms here. I've written 5 of them here. If you know what those are, you think you know what those are, pause the video right now and fill them in. I'm going to go through them. So amplitude is the amount the curve either goes up from or down from this middle line here. So you can see this line is where sine theta equals 0. This line is actually called the principal axis. So I'm going to put that on here. Let's do y equals 0, because that's the line about which the function varies equally. It's another way to say that. The bump above the principal axis is going to be the same as the bump below. Okay? So amplitude is this distance, this bump. There's the amplitude. Right there. And it's the same as this distance here. That would be the same. Okay? So you can have amplitude measured either way. It's positive. Okay. What is the minimum of this function? That would be the minus 1. and the maximum, by the same token, is positive 1. Now, what is the period? Now, the period is the amount of time on the horizontal axis it takes for the function to do one full cycle. And so, given that definition, pause the video and see if you can tell me what the period is on this one. Okay, if you said 2 pi, you're right. 2 pi is the amount of time it takes to do one full cycle. So that's going up from 0 to the max, back down through 0 to the min, and then back up to 0. So every 2 pi, it does the same thing. Now let's take a look at the unit circle in that. So this diagram relates very closely to the unit circle. And one way to think about it is this diagram is just the unit circle opened up and rolled out. So let's take a look. Sine 0 is right here, and that's 0 pi. So we have no height above the x-axis. So sine of 0 is 0, and that is indeed, that's this point. We're at 0 radians along our x-axis. So then when we go to pi over 2, or 90 degrees, sine of pi over 2 is 1. Now we are 1 above the x-axis, and guess what? Pi over 2, we are 1 up above. Rolling right along around the unit circle, we come back around to 180, or pi radians. Now, sine of 180 is back to 0. Indeed, there's sine, the y value, and guess what? Here at pi, at 180, we're back to 0. Now, rolling on along another pi over 2 radians, or 90 degrees, we get down to the bottom here at 270, 3 pi over 2. Sine of 3 pi over 2, or sine of 270, is negative 1. And indeed, we're here at negative 1 at the bottom of the valley. And then finally, rolling all the way back around, full circle around the unit circle, 2 pi radians, we're back at sine of 2 pi, or sine of 360, is 0. And indeed, here we are back at 0. So you can see how the y values go from 0 to 1 to 0 to negative 1 back to 0, just like on our graph, 0 to 1 to 0 to negative 1 back to 0. So this is directly related to that. All right, let's do y equals cosine theta on, again, the same range, minus 2 pi through 0 to positive 2 pi, or minus 360 to positive 360 degrees. So I've gone ahead and labeled the axes. Here's your theta axis, and here's your cosine theta axis. I'd like you to pause the video and mark this up and make it ready to put the cosine curve on it. All right. So the horizontal axis is the same as the sine graph. We're just graphing from negative 2 pi through all of the angles to positive 2 pi. So that's from negative 360 to positive 360. And then the vertical axis is also the same. The standard function, cosine theta, the maximum it's going to be is 1 and the minimum is going to be minus 1. So this set of axes is identical. Now I want you to pause the video and maybe get out your calculator or just do some critical thinking with the unit circle. I want you to make this graph. Do it from minus 2 pi to positive 2 pi, and I know you can. All right, let's do this one step at a time. I went ahead and put my unit circle here, and I just labeled my 4 points at my pi over 2 intervals, or my 90-degree intervals, so I know that when theta is 0, cosine theta is 1. So cosine theta starts up here. Doesn't start at 0, because cosine of 0 is 1. And then when we do pi over 2, or 90, if you put that in your calculator, you're going to get 0. We know this already because that point is 0, 1. So cosine of pi over 2 is 90. So now we're at 0. Cosine of pi is going to be 180, so we're halfway around the unit circle. So cosine of pi, remember cosine is the x value, is negative 1. So that one's going to be right down here. And then finally, cosine of 3 pi over 2, that's going to be all the way around at 270. That's back to my 0. And then finally, my cosine of 2 pi, I'm back to my 1 here, so I'm back up here. So now I can connect my dots. I'm going to try to make it curvy. That's pretty good. Doesn't look V-ish. You want to avoid that if you can. Make this look a little better. So if you're not there yet, pause the video and go ahead and complete this graph to negative 2 pi. Okay, so this graph just continues on in the same way. And of course, again, we have our maximum here at positive 1, our minimum here at -1. So now we can say some things. Actually, before we go do that, what do you notice about the cosine graph when you compare it to your sine graph? Maybe flip back in your notebook and take a look at both of those and then come back with a thought. Okay, one thought is they look almost exactly the same. And the truth is, they really are the same curve. This one is just shifted 90 degrees. Okay, it's shifted. To get sine, you just need to move this 90 degrees that way, and then you have the sine graph. Because remember, the sine graph rises out of 0. So if we just add 90 to this value, we're going to get to here, and it's going to be the sine graph. And indeed, a lot of the relationships that you've been exploring in this chapter with the unit circle show you that sine and cosine are related by 90 degrees. Okay. Other than that, what are the differences between sine and cosine? All right, let's take a look at those parameters we put up for the sine curve. And indeed, they're the same for the cosine curve. The amplitude is 1. We're just 1 up or 1 down. That's our amplitude. Our maximum is 1. That's as high as we ever get with cosine. Our minimum is -1. Again, that's the lowest we ever get with cosine. Our period is 2 pi because it takes 2 pi radians to come back to where we started so we can repeat the pattern. So that's our period. And again, our principal axis, the horizontal line above which it's the same below, so that the graph could be kind of reflected across that, is y equals 1. So that's what we put there. So these attributes are identical. The only difference is that 90 degree shift between cosine and sine. All right, let's take a look at a variation. So here's y equals 3 sine x. I'm using x instead of theta, same difference. We can just do that. So now I've got sine x, so whatever value comes out of the sine function, I'm going to multiply it by 3 before I get my point on my graph. So let's go ahead and make our graph. By the way, you can enter this into your calculator quite easily. I will put links below the video in the description, but you should really be comfortable making hand graphs. In fact, you will be asked to make graphs on portions of the test without the use of your calculator. So you're not off the hook for that. Okay, so this number, I'm going to tell you, affects the amplitude. So instead of being an amplitude of 1, this is going to be an amplitude of 3. And we'll talk about why that is. But right now, let's just go ahead and label our vertical axis. So it's going to go between 3 and -3. Now we haven't changed the period. There's a multiplier that can be put here that will change the period, but we haven't done that. So we're going to go from just before, just like from before, we're going to go from -2 pi to +2 pi. So we can do this, x to 2 pi. Okay? So now it's going to look pretty much the same. We're going to do the same kind of thing. This is sine, so it's going to start here. We're going to go up to 3, back down to 0, down to -3, and back up. Down to -3, back up to 0, up to 3, and back. And that's pretty much the graph. Now my amplitude is 3. So amplitude equals 3. Now my max, what's my max? My max is 3. My min is -3. My period is still 2 pi. And my principal axis is still y equals 1. I haven't moved the graph up or down. So this shows you that the number on the top outside multiplied directly on the function, this affects and actually is the amplitude. And that makes sense. Let's take a look. This right here is pi over 2, or 90 degrees. So if you do sine of 90, you get 1. Or sine of pi over 2, you get the value 1 comes out. So sine of pi over 2 is 1. Then we're going to multiply it by that 3, and that gives us this point here at 3. So our amplitude went from being 1 with sine x to being 3 with 3 sine x. So that's really all the change that this multiplier did. It just made the graph bigger. All right, so now let's take a look at this one. Instead of the 3 being out here in what we know is the amplitude position, Now it's inside the sine function. It's multiplying my x. So this is going to change the period of the function, and I'll show you how that works. So we're going to make this graph. So I'm going to go ahead and make my axes. My maximum on this one is going to be 1, and my minimum is -1. Now, before I scale my horizontal axis, I need to think about what my period is going to be. When x is 90, sine x is 1. But before we take the sine of x, we're going to multiply that by 3. So when x is 90, or pi over 2, we're going to take the sine of 270, or 3 pi over 2. So the result is going to be a different number that comes out. So the period is going to shrink it down. So this multiplier changes how the period works. And let me show you that. All right, so here's a little simple equation that lets you figure out the period when you have a multiplier in front of what's inside the sine function. So here it is for sine b of x. So b is this variable. In this case, b is 3. For sine of bx, the period is going to be 2 pi over b. So you're going to divide that out. And this makes sense because when I don't have a multiplier, when there's nothing there, it's like there's 1 there. So if I did 2 pi over 1, it's just 2 pi. So now that I have my equation for my period, I can go ahead and plug in my b, which goes on the bottom there. So I have 2 pi over 3 is the period. Now I'm going to simplify this graph by removing this condition. Maybe we'll return to it in a minute, but right now I'm just going to take it away. Okay. So the period, 2 pi over 3, is the amount of time it takes the sine function to do its full turn. So I can use these tick marks, and I can call this one 2 pi over 3. And then so this one would be pi over 3. That's halfway from, so this would be 0 pi over 3, 1 pi over 3, 2 pi over 3. And then we know that sine goes like this. And I have my function. So let's take a look. My amplitude is still 1. It's 1 high. My period is 2 pi over 3. My max and my min are still 1 and -1. And then my principal axis is still the y-axis, which is y equals 0. Now, if I wanted to continue this graph, I could just do that, extend it out. So this one would be 4 pi over 3. And this would be pi right there. So pi over 3, 2 pi over 3, 3 pi over 3, which is just pi, 4 pi over 3. So have we satisfied this range? Not quite. We could go out 1 more pi over 3 and get 5 pi over 3. We could actually go to 6 pi over 3. So we could get a whole nother copy of our sine graph, or 1 more period inside of 2 pi. So that would allow us to do it 3 times. And that corresponds with that. Okay, let's do 1 more. 2 cosine, different function, 2x. So I want you to go ahead and pause the video and do your very best to create that entire graph. All right, so I've labeled my axes. I checked out my period. It's 2 pi over b. In this case, b is 2. So it's 2 pi over 2, which is just pi. So I labeled my axes from pi to -pi. And of course, I put the range up that corresponds with the period. Okay, so it won't always be that way, but this, for just sake of teaching, I did that. And then I noticed that my amplitude is 2. So I put 2 as my max and -2 as my min. So if you didn't get this far, go ahead and copy that in and then sketch in your cosine graph. Okay, so here it is. Cosine starts at 1, but we're going to multiply that by 2. So our max is now 2. And then 2x, here's our period. So we're going to dive down to pi over 4, bottom out at -2 at pi over 2, climb back up to 0 at 3 pi over 2, and then finish up at pi with a maximum of 2. And then going backwards into negative land, it's the same thing. So cosine graph, remember, doesn't start at the origin, starts at the max, and it goes on like that. One last graph, I promise. So I've twisted this up a little bit. Your amplitude is now -4. We're still using the cosine function. And now your b is not just a number, it's the x over 2. So you're going to have to think about what the period is. So go ahead and pause the video, figure out the period. Let's do that. All right. So when I do that, My b is 1/2. X over 2 is like x times 1/2. So 2 pi over 1/2 makes 4 pi. Now check out our range. We're not going to graph a full period of this function because we're only going from minus 2 pi to 2 pi. The full period is 4 pi. So we're going to get a partial graph here. So now I can make my axes like this. 1, 2, 3, 4. 1, 2, 3, -4. I'm going to 2 pi and to -2 pi. Now I'm going to get a full period from -2 to +2 because that is 4 pi, but I won't get it in the positive side and again in the negative side. It's going to take the whole range here to get a full period. Now 4 is my amplitude, but the negative means I'm going to start at -4, okay? And then I'm going to come up. My halfway point is going to be at pi, so I'm going to come up through pi and there, and we'll do the same thing here at minus pi and come up and do that. So this is the graph of that function. Take a look at it, think about it, make sure it makes sense, and thanks for watching. All right, now that you've watched the video, take a minute and jot down any remaining questions so you can bring them to our next class. Also remember, you can watch the video again. Maybe that will deepen your understanding. If you like the video, please click like and subscribe.